Let's take a look at solving simple exponential equations. First, we have a property that says if we have two exponentials equal to each other, where the base is the same, so we have an a for both, then we can set those exponents equal to each other. We call this move, or this technique, equating exponents. Notice you have to have a single exponential on each side, and those exponentials have to have the exact same base. So let's solve this one. You see an exponential on both sides. They do have the same base of 3, so that means that we can go ahead and pull off those exponents. 2x is equal to x minus 1. Go ahead and subtract x from both sides, and you get x is equal to negative 1. As your solution, we can go back and check. Put a negative 1 in the left, you get 3 raised to the negative 2. Put a negative 1 on the right, minus 1 is negative 2, 3 raised to the negative 2, exact same thing. So your answer is x equal to negative 1. So what does this really mean with respect to the graphs? We can graph each of these functions. So here is y equals 3 to the 2x. Our two axes are x and y. And then we have the function y equals 3 raised to the x minus 1, which is the basic graph shifted 1 to the right. Remember x minus the way you shift it. This one with a 2 multiplies that exponent and makes it grow faster. And so what's that mean for us? Right here at negative 1 is where they hit. And that is what we found when we set these two equal to each other and solve for the x. It's really asking you for the points in common when those two are set equal to each other. So at negative 1 is the x value solution we found. Substitute negative 1 in, you get 3 to the negative 2, which is 1 over 9. The intersection point of those two curves is negative 1, 1 over 9. The solution to this is the x value, which is just negative 1. Just a reminder that when you're solving any equation and saying somebody on the left is equal to somebody on the right, you're really looking for the points at which those two curves intersect each other. So you could grab your graphing calculator and graph them and find it that way as well. Here's another one. It looks like they don't have like bases, but 4 is really 2 squared, so let's write it as 2 squared. Keep the exponent plus 1. And remember, this is a superpower here because he's on the outside of the parentheses, so we multiply those together and get 2 to the 2x minus 2 is equal to 2 to the 3x plus 1, which means now, like bases, we can equate the exponents. 2x minus 2 is equal to 3x plus 1, and let's go ahead and solve that. We're going to subtract 2x from both sides, and that gives us here on the left those, sorry, get my highlighter, this guy is going to be subtracted. He goes to 0, and you get a negative 2 here, so we're going to move that 1 as well, so subtract 1. We get negative 3 is equal to x. Let's go ahead and check that. You can put this negative 3 back up into your function here and verify that that does indeed work. Let's do one more that has a slightly different look to it. For this one, we've got a fraction sitting here, but it's got a 3, and 9 is 3 squared, so let's try for like bases with 3's. On the left, remember, 1/3 is equal to 3 to the negative 1 using negative exponents. So let's write that as 3 to the negative 1 raised to x minus 1. 9 is 3 squared to the 3x minus 2. And multiply in that superpower. 3 to the negative x plus 1 is equal to 3 to the 6x minus 4. We're just multiplying in. And here 2 times 3x is 6x. 2 times negative 2 is negative 4. Now we can go ahead and equate exponents because we have like bases. Let's move all of the variables to the right by adding 1, move the constants by adding 4. When you do that on the left, you get a 5, and on the right, you get 7x. Let's go ahead and divide by 7 to get that variable by itself, and you get 5 over 7. You can check that by substituting back into the original equation and verifying that is correct. And that is a little bit more difficult one, right? But I think you can still do that. Now, what happens if you can't equate exponents? And this is the tough part. When you get here, this 2, you can never rewrite 9 as 2 to some power. So we are not going to be able to rewrite the 9 and then get like bases of 2. So we have to do something else. That is a different technique. And you can find that tool for your toolkit by looking for complex exponential equations on my YouTube channel. Hope you're having a great day.